but apparently you're not a compelling speaker because they didn't move down. Like you guys at the back, you'll never be able to read those slides, but all right, maybe you're munching on bacon still. It was a bit stressful this morning. You saw me push around, but my biggest decision was, should I wear a green shirt? I don't know. Like, is that too forward to say we're talking? Anyway, I put on the green shirt. We often we hold a building science training camp in spring, and we often like to do debates, kind of see both sides of the equation. So Steve posed this question: are we the greenest community? That's a good question. So it's going to be less of a debate, although you are allowed to heckle today. That's fine. I know some of you really well, and I know you're okay at heckling. So I'm going to show you one side of the debate, and then you can think about yourselves as you wander the community. For example, Westport and Watercolours. Think to yourself whether this could, in fact, be the greenest community. We'll start with, I always like to do a little bit of history. Maybe it's my age, but I like to give a little bit of history, some of the connections that we can make from history. I think there's some circularity to this whole green conversation that I think you'll be interested in. We do want to talk about the compelling trends because, you know, I would say the bar for green, or the shade of green, has changed over the years as to what exactly constitutes green. And then, you know, I'm going to highlight some of the features of green and what that might mean, and highlight obviously things that Land Ark and Watercolours are doing. And I always like to make sure we understand the benefits of green. You know, I would say the synergies of green and how it improves our lives and our communities. So we'll do just a little bit of that. And we do have time for questions, Stephen. I think we left hopefully 10, 15 minutes for questions. I do talk fairly quickly, so if you need me to slow down, let me know, or ask questions. But in general, try to keep the questions at the end. That way I can win the debate is really what we're, yeah. So I thought, you know, I'd start with the definition. And green buildings, first, in both a structure and application process, they're environmentally responsible, resource efficient throughout a building's life cycle. That's pretty interesting. Planning, construction, operation, maintenance, renovation, and demolition. That's U.S. EPA, Environmental Protection Agency. I have a lot of time for EPA. They've done some pretty cool stuff. They tend to get, in the U.S., politicized, but in general, they've done some pretty good stuff. But that's green building. We said it has to be green community. Okay, green community design is a framework for master planning, design, and construction, tool to create a symbiotic relationship between people and all aspects of the built environment. But I love this line: to create communities that are as connected as a forest. Isn't that kind of a cool line? The connections. And so clearly one of the things we need to do today, if I'm going to make the debate point, is to say what are the connections to our indoor world and our outdoor world. Everybody okay with that? We have two worlds, and I want to contrast those, or talk about both of those and how they are synergistic in the built environment. So we'll start with that. I do want to start and say there are some programs that help with this. We in Canada, for example, since 1982, the yearly research was mid-70s, but the R2000 program, maybe you remember, some of you would remember the R2000 program. You know, it was kind of the flagship, if you will. And all of those programs grew out of, including Passive House in Germany, grew out of Canada's R2000 program. Were you aware of that? The Germans came over in 1988, and looked at the R2000 program, took it back to Germany, and created the Passive House program, which they're now bringing back to us and saying, this is the most efficient house. And yes, they put R2000 on steroids and did make it more efficient, but the history, the science, all came from Canadian building science research. The one sort of middle, zero energy, that's Department of Energy's zero energy program in the United States. Again, all based on Canadian building science research, all the same tenets. But so that's just energy. Our focus for the most part in Canada has been energy up until more recently. There are a whole bunch of green programs. Built Green is a very common program. BC, Alberta has a program called Built Green that has a whole checklist of items. The LEED Canada, many of you would have heard of LEED, right? LEED Homes, the checklist of the 7 different elements of LEED. A little program called Active House out of, it's out of Europe. I got to speak there in Italy. That's why I bought these shoes, because I had to, when you go to Italy, you got to buy better shoes, apparently. So I was able to speak, and it too is an interesting concept of what they call a radar, filling out your radar of different aspects of green. Living Building Challenge, and Stephen, where's Stephen? Sorry, Stephen's been, I keep looking at you, Stephen has been exploring and looking at the Living Building Challenge, the well technology. Well is kind of interesting. They took all of the building science, and they give deference to it, and they talk about it, but they've done it from I'll say from a capitalist point of view. That is, what could we do with wellness and help businesses, if you will. So kind of interesting that the financial guys got into the green side, which I think is pretty important. And then a big program out of UK, One Planet. So green building programs. What I wanted to show you is they have a lot in common. Here, for example, is the very simple tenets of the Energy Star program. The most popular, the most successful energy efficiency program in housing ever in North America. Over 2 million houses, over 100,000 in Canada are rated to Energy Star. Very simple principles, 20% more efficient. I'll read it for you guys at the back because you didn't move up. Higher levels of insulation, air tightness tested. Notice balanced ventilation. Notice reduced peak electrical demand, tested and labeled. So that's Energy Star. If you look at LEED, for example, LEED has these categories that take us through the energy and atmosphere, materials, resources, water efficiency, innovation and design, sustainable sites, regional priorities, so on and so on, expanding from the building out to the entire community. And they haven't said in LEED, they do have LEED for communities, in a LEED house, you don't necessarily have to consider beyond your property, but you do get points for what's called location and leakages. For example, I have a little cottage in Southampton. I can walk to a hospital, I can walk to a library, I can walk to a grocery store. Guess what? That gets me huge LEED points just because I put the house in a place where I can walk. What do you think Watercolours has done? Isn't this kind of cool? You can walk to what? Is there anything on the list that you can't walk to? A medical center and so on. That's very important from the LEED perspective to take, obviously focus on the house, but where can I go further? So I think those are kind of interesting. Then look at the Living Building Challenge. And again, you may not be able to read, but in this case, they use the emblem of a flower, the petals of a flower. Oh, that's kind of interesting connection to the environment, right, to describe their elements with respect to petals in a flower. But notice the similarities: water, place, energy, health. All of them are saying almost exactly the same thing. And that's not a bad thing. That's, of course, a good thing. And they come from different perspectives. As I said to you, the WELL program is more from the financial side, the real estate side, saying we should be promoting exactly the same concepts, but we should be promoting it through the real estate and the finance side to garner more interest. LEED, for example, was designed primarily by architects. WELL has been designed, or at least promoted, by primarily real estate and financial folks. Isn't it good that everybody's using basically the same benchmarks and then saying, but our own focus, where we're coming from. So the energy programs were engineers, LEED was architects, WELL and Living Building Challenge. The Living Building Challenge is more from the environmental side, and the WELL program is more from the financial side. It shows us that everybody's working, and there are some commonalities to this that we go, okay, we're on the same page. Everybody's singing from the same hymn book, if you will. So those program elements, which I think is pretty cool. And then you contrast or compare that to the Land Ark way, and there's a great brochure, and I encourage you to pick it up, and all the things that they're doing. And notice, very similar, right? They've highlighted three in this case: super insulation, super ventilation, super built environment, super tight building envelope. So very common themes, very similar themes. I want to just show, just for a second, I'm going to go back in history a little bit, and I want to highlight two items: the super tight building envelope and the super ventilation. We have this odd thing in Canada. We started building really tight houses through the R2000 program in the 70s. We built tight, tighter, tightest. Anybody have a problem with that? What's the problem with building tight houses? For condensation, indoor air quality problems. And we have this angst over, oh my goodness, we don't want them to be too tight. That would be a problem. Well, let me share with you a little history of that. And what we really need to think about is the angst between energy, that would be air tightness, and notice on the left-hand side that unwanted air leakage accounts for 30% of our energy bill. You got a 100,000 BTU furnace, 30,000 of that goes to heating unwanted air leakage. That sounds like a complete waste, doesn't it? So we've always wanted to shrink that piece of the pie. On the right-hand side, we've known for a long time, Ben Franklin, you may not know this, and amongst all the other things he did is in the United States, he was also an expert in ventilation, in air quality. And Ben used this phrase, I am certain that no air is so unwholesome as air is in a closed room that's often breathed and not changed. And mainly public buildings, but you would hire Ben and he would come out and look at the public buildings, say the library, the church, and go, okay, I see you got 300 people here. I need this window open 2 inches and I need this window open 2 inches to create a nice draft, a nice flow. I need the bottom of the building windows open, the top of the building open in the wintertime to create a nice draft. Ben understood that I need ventilation. And our code started to reflect that in as early as 1904 to start in New York to think about to think about moisture, my apologies, I was getting to underwater, to think about air quality as much as we thought about water quality. So we've known about this angst for a long, long time, the research has shown. And then we go, but outside air, is it any good? Well, this is a really important slide from the EPA, when they institute the Clean Air Act. 1968, major urban centers in North America had incredibly bad air quality. As a result of what? What was causing the bad air quality in those cities? Combustion in buildings, combustion of vehicles, and so on and so on. And they put into place the Clean Air Act, which now has cleaned up cities. And if you look at the data, in urban centers, like right inside cities, air quality outside has been improved by over 80% by the Clean Air Act. Isn't that interesting? So Ben was worried about inside, now we got to worry about outside and those connections, that circular nature of how do we do this? How do we make sure that all of this works? And here's one of our heroes in the building industry, Harold Orr, who was just given the Order of Canada a few years ago for his contribution. He was one of the early reachers on R2000. He effectively created and invented what's called the blower door, which we used, where's Stefan, which you use every day to do air tightness testing on Watercolour's houses. And Harold was clearly focused on air tightness because they couldn't figure out where the energy was going and then figured out, he's the guy who kind of decided that it's 30%. And Harold's been saying for over 40 years, we should make buildings tighter. And I happened to be with Harold when he was given an award in the United States. He's considered the father of energy efficiency in the United States. He's considered one of the founding fathers of the Passive House program. So I'm glad he got the Order of Canada. And when he saw the technologies that are now available, he's like, yes, in my lifetime we can get these done. And his angst was on two different sides. And so I'm going to give you the solution. So I'll ask it this way. Exactly how many holes would you like watercolors to leave in the walls or attics of your house? How many holes would you like them to intentionally leave in your house? And the answer would be? None. But when would you like fresh air in your home? Isn't that interesting? You guys get this. Builders have had this angst. Well, you want to make them too tight? I don't know. Homeowners always get this. I don't want any holes, cracks, leaks. I don't want drafts, dust, bugs, and so on. But at the same time, I want my house to have proper ventilation. I mentioned Ben, his ventilation system was what? How did he get ventilation in buildings, Ben Franklin? By opening windows. Somewhere along the line, we stopped opening windows. Why? Air conditioning, absolutely. 1963, 12% of all buildings in North America had air conditioning. Now, about 80% of all buildings in North America have air conditioning, which means we used to have our windows open all summer, and now not so much. And noise and dust and security and energy costs, we stopped opening windows. So the solution in the green building world, we still want that connection to outside. We still want those windows, don't we? We just don't want to open them. So we want to be connected to the outdoors, but we don't want to necessarily use them for our ventilation. And the quintessential element is then use this computer-controlled, this is exactly where Harold went yes, when he saw this computer-controlled pinpoint air sealing methodology called Aero Barrier that Watercolours was one of the first to institute here in the province and say, I just want to get rid of all those small little holes, but at the same time, I want whole house fresh air. In fact, twice filtered whole house house fresh air system. And you can imagine how nice it must have been during the wood smoke issues. You go, what do they tell you to do? Stay indoors. But the indoor air quality is not necessarily good. So what do? I seal off my house, make sure the wood smoke's not getting in, and then just bring in the right amount of twice filtered fresh air to get rid of the wood smoke. These are the kinds of circular connections that we need to understand, how we connect. And this, in my world, this says we truly are a very green community when we're able to think about our indoor environment, our outdoor environment, and assess. On the days where it's really beautiful, like today, do you think you should open a window right up until about 1 o'clock when it gets hot and you go, no, I don't want that anymore, but I still want the fresh air, right? So all of these become the intricacies of the design of the indoor versus the outdoors. I think kind of cool. And then I need to switch gears and move along a little bit. I just wanted to give you that one example. And I need us to understand the new imperative, which is greenhouse gas emissions, which we shorten into carbon dioxide. You'll hear this. So we need to understand that. There's a whole bunch of gases that are greenhouse gas and impact greenhouse. But we take all of those gases and equate them down to carbon dioxide equivalents. And then we shortcut that by saying we just call it carbon emissions. So if you get confused, what are they talking about? Black powder in the air? No. We're talking about carbon dioxide equivalents, and we use the short form of carbon. And we've made this commitment. Personally made this commitment, and everybody in the world's made this commitment that we're going to see a reduction of 40% by 2030. A short 6.5 years from now, we're going to reduce. And I don't want us to wait till 2029, December 31st, and go, what was that now? I think we need to work on this a little bit sooner, and we need to be zero emissions by 2050. That's what the world is saying. And every major manufacturer is saying. Amazon, Google, the car industry, they're all saying we're going to get to zero carbon by 2050. So I need to give you just a little bit. When we say carbon, as I said, carbon dioxide, there's two types of carbon. There's the upfront embodied carbon to make a house, to build a house. And clearly the greenest thing you would do is never build another house. Everybody okay with that? You would never make concrete. You would never cut down a tree. Well, no. We have a housing crisis. We have an affordability issue. We still have to build houses. So we have to minimize the amount of carbon that's released while we build the house. And then clearly we need to think about the operational carbon. That is, what does it cost to build? What does it cost to operate that building? And when we talk, we're going to talk this morning about the operational carbon to give you a sense where that's about. But it's all about its life cycle, right? You've all heard cradle to grave, understanding. The good news is houses last a long time. What's the oldest house in Westport? What would it be, a couple hundred years old? Houses last a long time, so we have to worry less about the embodied, because we know the house is going to be here a long time, and worry more about the operational side of that. And when we talk about the operational side, it really comes down to this: how much energy you're using, and where's that energy coming from? Everybody okay with that? How much am I using, and what's the source? If you still got the old coal stove in the basement, that might not be a good thing. You might say, I'm burning wood, but it's on a really high-performance wood burner. Fair enough, but it is emitting carbon. Natural gas is cleaner burning. Or what about electricity? And then the question is, where does the electricity come from? How's it generated? We used to have coal-fired in the province. We don't anymore, and so on. So it's always about the consumption versus the fuel choice that we need to think about. And the good news is we have a really good metric called EnerGuide. Anybody seen an EnerGuide rating before on a fridge, on a dryer, and so on? We have an EnerGuide rating system for houses that'll tell you how many gigajoules. There's a new term for you. What's a gigajoule? I don't know. Well, a gigajoule is 278 kilowatt hours of energy. Okay, it's just a new metric we're going to have to get used to. And if you were building a zero energy house, how many gigajoules would it use? That was a pretty easy hint. Zero. I know. It was breakfast. You got to be able to answer that. And it includes the energy for heating, for cooling, for ventilation, all of the energy inputs, and we get this really nice scale on this list. My brother's house came out at 263. He's like, yes. I said, no, Jim, this is not a golf score. This is more like your golf score. The lower the number, the better, not the higher the number. We want to be down near zero is where we'd like to get to. So that gigajoule scale we now have. And we can turn those gigajoules into carbon dioxide equivalents if we knew what was the fuel source that was used to generate that. So that's in fact what we do. I don't know how well you'll be able to see at the back, but just to give you a quick sense, it varies a lot. Alberta is almost all coal, going to be all gas within 5 years, but right now 80% coal. Their emissions, 640 tons of carbon dioxide for every kilowatt, carbon dioxide It's in grams, sorry. Per kilowatt hour of electricity generated, 640. You just don't need the. And then Ontario is 28. Why? Why are we cleaner? Where's our energy come from? Our electrical energy come from? Comes over the Niagara Falls and the nukes, right? The nukes. And you might have problems with nukes and so on, but from a carbon perspective, nothing better. Well, the only thing better than nukes is hydro. Then it's nukes in terms of carbon emitted while they're generating electricity. Yes, we got to worry about the waste and so on, but from a carbon emissions, nukes and hydro are really, really good, really clean. Notice Quebec is 1.9. You can start to imagine the decisions you make in a province, if you're a builder, might vary a little bit, right? Depending on where that energy is being generated by. If you were in Alberta, you wouldn't immediately switch to an all-electric house, would you? Because you go, wow, that's not great. Until they get a cleaner grid, you want to do something a little different. So first we have to think about energy consumption. That's always good. Alberta, Ontario, Quebec, always good. But then thinking about what fuel source am I going to use. So give a little sense of that. That's, of course, what a net zero house looks like. I mean, you could do that, right? You could in Quebec. In Quebec, you go, do I even need that? I've got such a clean grid. I'm using electricity. Do I really care? In Alberta, you would do that. This is a real house in Caledon area, but it's not a good decision. And what, of course, Land Ark Watercolours has been working on is what is the optimum? How do I do this in an optimal setting is where we want to get to. And so lots of numbers on the page, don't worry too much about it, but we take the natural gas, the electricity, we apply that to the energy use of the house, and it comes down to this. A typical house in Ontario built to code, 3.4 tons of carbon dioxide emitted into the atmosphere every year. 3.4 tons. And what we really would like it to be is zero. How do we get there? That's really the challenge. And we need to get to zero by 2050, but frankly, the house is going to last 200 years, so if you're building a house today, you'd really hate to say, yeah, I'll do that later. I'll get rid of those later. At time of new construction, we really need to get this done. So that's important to us. And so there, in terms of gigajoules, remember I said energy, there's a typical new house, 85 gigajoules. There's a typical net zero house, 40 gigajoules. What you need to notice on that slide is, notice where the energy's going. That is, on the left-hand side, 50% of the gigajoules go to heating the house. On the right-hand side, 64% of the energy goes to whatever you and I are doing. We're doing the same stuff, showers, cleaning, so on and so on. It's just that they become a bigger piece of the pie. So about the most, the best a builder can ever do because of occupant loads is get around, what, 35 to 45? What's been your lowest in that gigajoules stuff? And 35 to 45. And then it comes down to, and we're not saying you can't shower ever again. Don't get me wrong. We're not saying you can't run your TV, but what we are saying is if your occupant loads represent 65%, the only way to offset that it would be to start adding energy yourself, right? Renewable energy. So it becomes, what's kind of cool is the builder does their bit, Land Ark, Watercolours does their bit, and then you go, okay, now it's up to me to decide either reduce my consumption or add some generation. And the good news is if I've built the house correctly and I got enough roof area facing the right direction, I could get to zero. Everybody okay with that? That's kind of the concept. And if I said to you, and Will, where's Will? Will's the solar guy. He'll be chatting with you at another time. Will's going to tell you that one solar panel, the typical 18 square foot 3x6 solar panel you see it put on a roof, it can generate in Westport over the course of the year roughly 1 gigajoule. Actually, new panels today, 1.2, 1.4. But just for easy math, I would say one solar panel generates 1 gigajoule over the year. So clearly, you could make a brand new house net zero by adding how many solar panels? 85. If you did a net zero house, net zero ready house, you'd only need to add 40. Pretty simple math, right? And now it becomes the cost of those extra 45 solar panels times $500 a panel and so on. Would I be better off to do something to the house to get us to zero? Everybody okay with that concept? Are we okay there in terms of film? You're okay? Fair enough. So just imagining this optimization, that's really what this is about. And so that really nice reduction. And let's be really clear, we've done a good job in Canada. For a house built in the 1990s because of code change, because of other bits of science, Houses built in the 1990s use roughly half the amount of houses built in the 1970s. Good news. Houses built today by the worst of builders, and there are no bad builders, by the minimum code built builders in wherever, use about half the amount of energy as house built in 1990. Here's the challenge. If we're going to meet our goals, the 2030 goals, we got to cut that in half yet again. And it turns out it's the next logical step. We need to get there. Codes are going to get us there by 2035. But I need to make it really clear. If you build a house today, 10 years from now, it's obsolete. Like, it just doesn't make any sense. If we have to get there by 2030, 2050, why aren't we doing this now? And the good news is we have the technology to do it. That's why you're here, is to say, what does this look like? What exactly are the choices that are being made in order to make this happen? And just so you're really clear, the US is on exactly the same path. I just was in Atlanta. They actually give tax credits there to the builders. If they build a net zero ready house, what they call zero energy ready, they get a $5,000 tax credit. And the largest builders in the United States, these guys build, how many you built? 25,000? No, yeah. Sorry. The largest builders in the United States build 40,000, 50,000 houses a year, and they're all clamoring to get to zero energy because they want the $5,000. Isn't that kind of interesting? Now, can they do it for $5? And the answer is no. But they're looking at it, and they're trying, and so the U.S. is moving. But I want you to notice the right-hand side of the screen that takes not only zero energy, but it also puts the same categories that all the green building programs. And it's really important that we understand this, that energy efficiency isn't energy on its own. It's also about health, comfort, technology, quality, durability, all of those same scales. And it turns out when you build a zero energy house in the US or a net zero ready house in Ontario, Canada, you always end up simultaneously making houses healthier, safer, more comfortable, more durable, more resilient. Isn't that kind of interesting, right? That the same things we do for energy efficiency, and I'm going to highlight those elements as we do the presentation. And that the fact of the matter is, I'll just check my timing, the fact of the matter is there are choices, alternatives, and options. Frankly, there's only 6 or 7 things you can do to a house. We all know that, well, I'll just give you a little bit of the science. We all know that heat does what? How does heat move? How does heat flow? Heat rises. Turns out it's actually not true, but that's okay. It was a good try. It was a good try. You get half marks, because it turns out heat doesn't rise. What does rise? Warm air rises. Oh, it's an airflow mechanism. Warm, moist air rises. Heat actually goes from hot to cold. I'll give you an example. This winter, you went downstairs, you were going to go watch TV, or maybe, I don't know, shoot hockey pucks, whatever. You took your shoes off, you stood on the concrete floor in your own existing house, and how'd your feet feel on a concrete floor? Cold. That's your body at 38 degrees Celsius, losing heat to the ground at roughly 10 degrees Celsius. That's heat going down. And because we thought heat rises in the 1940s, we added a whole bunch of insulation to the attic. And because we thought heat rises, we insulated the basement floor with concrete. And what's the insulation value? Concrete. Well, it's 0.08 per inch, like it's nothing. And so that's why for all these years you go, oh man, and if you pour a slab tomorrow and don't insulate it, the next time that slab gets looked at is 200 years from now. What a shame, right? There's no way to do it later. So we have to think about the choices we're going to make today if we're going to make houses work. And it's really about those choices and alternatives versus, say, the solar panels. We could just phone Will Beardmore at Blue Water and say, send me 85 solar panels, I'll put them on the yard, I'll throw them out here, I'll put them on the top of my car, whatever. Or you could say, let's really optimize the enclosure and see what we get. Everybody okay with that? It's about the choices we make and understanding the science behind how it works. So let's talk about windows. Do you want more windows or less windows in your house? More. Here's again our connection to the outdoor environment. We don't necessarily want to be outside, we just want to pretend we're outside. Everybody okay with that? And maybe that's the environmental connection, but no, we do know that our lives are healthier when you put people beside windows. There's so many great things. Think about Westport and all the things I'm looking at now, and you guys are probably looking out at the back, that's why you sit at the back, you're looking out over the pond, that connection to our outdoor environment. But at the same time, we know that outdoor environment sometimes, especially in Canada, isn't always inviting. There's bug season, and then there's humidity season, and then there's snow season. There's all these times where we go, yeah, it'd be nice to be outside, but right now I just don't want to be. From an energy perspective, are windows good or bad? Historically, windows were bad. Single glazed windows, frosted up, cold as all get out. Turns out windows don't have to be bad anymore. We have technology now where windows can actually outperform the walls you put them in. Because windows have this really interesting thing. They can gain us energy, right? Certain days of the winter, they can gain us energy. The problem is those same windows in the summer can gain us too much energy. So how do we optimize that comfort? And what about that condensation risk? So again, the connections that we love, the big windows to the outdoors, how do we manage that? How do we do this and have the beautiful views, the beautiful windows without impacting the comfort, the condensation, energy costs, and so on? And so I'm going to show you some math. Remember gigajoules? How many gigajoules did we want to get to? 0. And how many are we at now in an Ontario code built house? 40, that's net zero ready. No, 85, right? Here's a house that was 100 gigajoules, and all I did to it is put in triple glazed windows, and I reduced it by 6 gigajoules. Not so bad, right? Made one choice and got rid of 6% of the gigajoules, which would mean 6% of the greenhouse gases associated with that building, and not have to compromise on my connection to the outdoors because I got big, beautiful windows. Isn't that kind of cool? By applying one phone call to one supplier saying, just give me not 2 panes of glass, but 3. Not 1 airspace, but 2. That improves the performance of the windows by 2 airspaces by about 30%. You might say, you might be thinking 100% or 50%. No, it improves the performance of windows by about 30% and puts them in a range where you go for it. I can now have windows, not forever, and not in all sides of the house. I don't want a glass house, but I can, in fact, maintain or manage that energy by simply putting in triples. And so triples are roughly equal to 6 solar panels. How much are solar panels? And it turns out the cost of triples is less typically than the cost of 6 more solar panels. So it's a good trade-off, right? A good compromise between the connections that we want to the outdoors and without blowing the energy budget and the carbon budget, if you will. But it has more important elements to that we end up with less moisture on surface, less condensation. And because we have less condensation, we can raise the relative humidity. We all know in Canada, one of the problems with old houses is they were really, really dry. And you say, I want to add moisture, kind of like outdoors. I want to be more like outdoors and have higher moisture levels. And the answer is, can't do it because I have condensation. When you put in triple glazed windows, you can allow the relative humidity to come back up into a healthy zone. I don't know if you know this, during COVID, the research was reaffirmed that the healthiest range to live in is 35 to 45 winter, 50 to 55, 60 in the summer. Healthiest range from viruses, bugs, dust, molds, and so on, 35 to 45 winter. Well, that's been a pipe dream up until now. When you put in triple glazed windows, now you can maintain 35 to 45 in the winter. You end up being healthier. This is well designed, well understood that our indoor environments in Canada were always compromised because of this condensation issue. Doesn't have to be compromised anymore. So you can see this connection where I can legitimately say windows are 6 gigajoules more energy efficient, but they are also add to the health of our houses, health of our skin, health of our nose, and so on, to help me with those elements. And it manages comfort. I'm now sitting beside warmer pieces of glass. And you've all felt that, right? It feels cold in here, and it feels like a draft. It's not a draft. It's actually the radiant losses. Remember we said heat goes from hot to cold. Turns out the body, the temperature of our skin, 38 degrees Celsius, 37 degrees Celsius internal, about 32 degrees Celsius on our skin. If you are sitting beside a big window that's at 10 degrees Celsius, your body's radiating heat out directly to that glass, and you feel chilled. And you think you got to put on the onesie. You know, I remember in our basement used to be all concrete. You basically had to wear oven mitts and a toque to go watch TV down there. And because you just felt this, and it's odd, it only came upon you after a bit, because the air temperature was fine. It's the surface temperature of the problem. So this ends up being more comfortable. See what we've done here? We're 6 gigajoules more energy efficient. We're healthier because we're in a better humidity range, and we're more comfortable because we don't have those surface temperature losses. And magically, it also means my heating system got smaller because I reduced the cooling requirements by about 30% by putting in the proper glass. Cooling requirements. Remember, we didn't used to have it, now we do. Turns out the size of the air conditioner in your house determines the size of heating and ductwork you put in your house. Cooling loads are bigger than heating loads. Cooling airflow needs are bigger than heating needs, and therefore we had to size systems because now we're doing cooling. Now we get to resize those mechanicals. See the synergies here, right, of the connections between energy efficiency and green building ideals. And again, you won't be able to read in the back, but I just want you at the back to imagine, close your eyes for a second, and just imagine all the benefits of big, beautiful windows. What can I do with that? The great views, the cozy spaces, the quiet retreat and respite. I just love this picture of, you know, the window seat, and what would you do there? You're reading, in my case, it would be reading the stories to the grandkids, right, and curling up and so on, thinking about all the great things that you can do with those windows and still have that connection to the outside, our connections when the outside environment is not conducive or when we need to be inside for privacy needs, whatever, we can still be connected to the outdoors, and that's 4 to 6. And then I want to move to, I mentioned basements earlier. Can you smell that basement right now? Anybody, give me the 4 words that describe the basements of most houses. 4 words that describe the atmosphere. Musty. Moldy, dank, cold. Dark, damp, cold, musty. And I say to builders, why do you build a basement? Well, because it's cheap living space. Well, it better be cheap because it's cold, dark, damp, and musty. And if we want it warm, dry, bright, and healthy, we got to do a better job, right? We got to do a better job. And the problem with basements is we're living in holes in the ground. And that isn't easy. It took man about 200,000 years to get out of caves. And the last 40 years, like, there's a good hole, let's live down there. We'll put the kids down there. We'll put the TV down there. We'll put the sewing room down there. No, it's not a great environment because it has all of these moisture sources. And if we're going to build and live in basements, then we have to do a better job of basements. Here, from a building science perspective, is how you build the best basement. This is an animation done by my partners in the US. The best of a retrofit basement, if you're finishing your basement, you'd put an insulated foam sheathing tight to the wall, and then you would use a spray foam at least in the rim joist area to make sure it's airtight and moisture lock, if you will. And then I'll just let this play a little bit. But just thinking about, and now I want to finish that wall, what do? Well, typically then I'll build a stud wall in front of that and either fill it full of foam, doesn't have to be foam, or more cost effectively to fill it with, say, a fibrous insulation. And this wall ends up managing moisture, which is our single biggest problem, but it also manages the heat flow without allowing condensation within the cavity. So that we drew up about, the animation's now 12 years old, that's an animation, and roughly what percent of builders actually do that? Well, it turns out about 2% of builders do that. They just kind of haven't figured it out. They're not sure people are ready to pay for basements. But now I get this really warm, dry, bright. So you can imagine, and I didn't take the picture because I wasn't able to get it. What I wanted to show you is how pleased I was when the first time I came to Watercolors and saw how I have to ask, how you guys do in your basement? Let's go have a look. There it is, spray foam on the ground, connected to spray foam on the wall, which means you call it the Yeti cooler. From a building science perspective, this foam is moisture resistant, does not allow for the growth of mold. It has the highest R value per inch, so I don't need to put as much down. And now I have this connection of warm, moist, dry basements. And the question is, what do you do with warm, dry basements? And you guys know, during COVID, houses changed. They're not houses anymore, are they? They are schools and offices and churches and recreation centers. This space, this truly livable space, lower living area, if only he was allowed. The real estate rules, any real estate agents here, doesn't allow you to claim that as living space, right? You're not allowed to claim it. But we should change that metric. I have a builder client who likes to say it this way: welcome to our 1,500 square foot house that has 3,000 square feet of developed space. What now? They're not allowed to say it's more than 1,500 square feet, but let's allude to and think about what you would do with that space, all of the things that would change your life, improve your life, that you could now do in that lower living area, now that you know. And the problem is nobody can see that, right? That's always the struggle with Stephen and watercolors, is that houses built, and you should see it's like there under the floor, and I wish I could show you that, but you just can't do it. And if you don't do it now, when can it get done? Never, when the house is torn down. What a shame, right? This is why we would say if you don't do it now, the house is obsolete the day you move in. What a shame that would be. So that's an example of basements. And then I mentioned earlier, I just want to watch my timing, sir. Let me do that. Yep, fine. I wanted to just show you this air leakage. Remember Harold Orr, the father of energy efficiency in Canada, Germany, and his whole focus for the last 40 years has been on air leakage control. And well, that's pretty simple. Don't we build our houses out of products that don't let air go through them? Drywall, wood, poly, foams. Sure. The problem is we put a lot of holes and connections in those houses, and we have this unwanted air leakage. And we're in Canada, and warm moist air does what? Rises. Warm moist air rises, which warm moist air rises leaving into the attic. And imagine this, warm moist air leaking into a cold attic. What does that sound like? What happens when warm moist air hits a cold surface? I get condensation. And this is new, because we only used to put like R8, maybe R20 in the attic. So the attics weren't particularly cold, so they didn't condense. Then we put in R20, R30, R40, R50. You'll see renovators doing it all the time. Top up your insulation. The problem is you top up your insulation, it stops the flow of heat, great, but it makes the attic colder. And if I didn't stop the warm, moist air, because pink fluffy stuff doesn't stop the warm, moist air, I end up with condensation. Here's the problem in the 16 million existing houses. I can't insulate them until I first air seal them. How do I do that? I got to go find these holes, these little tiny holes that allow warm, moist air to leak up into that attic. It's a super challenge. We struggle with this. 16 million existing houses that need to be renovated. And I got to make them airtight before I am allowed to insulate them because of this condensation, this durability challenge that we need to think about. And it represents 30 to 50% of the heat loss of a house. So in new housing, Stefan's here, just raise your hand. Stefan does all the performance testing for watercolors, a certified energy advisor's taken you've written way too many exams as I recall, that certified licensed guy who's doing, he's better looking than that guy, but if you see him. But this idea that when we test houses, what does that mean? That means fewer drafts, that means less dust, that means lower noise, that means not wasting money. And I think that's an interesting one. We all talk about what are the savings going to be, what are the savings? I want to take that away from you. What I want to ask you right now in your own house, how much money are you wasting right now? Because my mom grew up in Depression era. To watch her throw away a piece of tin foil, ooh, that was tough. Like, you don't throw away a piece of tin foil, right? You iron it out, you wash it, you put it in the drawer, you fold it up, you use it. You don't waste anything. And when I said to her, Mom, how much energy you wasting? Because I said savings, didn't catch it. When I said waste, what do you mean waste? What are you talking about, waste? And so it's think about how much you're wasting now. Or if you build a house and didn't test it, how much are you wasting? You know it's not a requirement to test house for air tightness in Canada. It's not a code requirement. It's a code requirement in 30 U.S. states now. Every house in 30 U.S. states have to be air tightness tested. In Canada, it's only the province of British Columbia that currently requires air tightness testing, even though it represents 30 to 50% of the energy loss of our houses. What a shame, right, that we want to get to. And as I just made that connection, more durable buildings because no warm, moist air leaks in to get condensation. Hopefully we'll understand that. And look at that, up to a 10 gigajoule reduction. How many do we need to get rid of? We're at 85, we want to get to 0. We got 4 for the 6 for the windows, we got 5 for the basement, now we get 10 for air tightness. Pretty powerful stuff. And what's really cool is when you do the air tightness, you do the basement, you do the windows, magically your heating system can get smaller, heating cooling system, because I don't have those instantaneous losses. Some really nice synergies here. The problem in the past trying to do these savings was I put in a heat pump, for example. I couldn't put in the heat pump because the heat pump had to be so darn big because the house was so darn inefficient. And so we are moving towards this idea that we can now make heat pumps viable. And you're going to say, remind me again, what's a heat pump? I just want to remind you of this. We used to have 60% efficient furnaces, then 80, then 90, then 95. We're at 96% efficient furnaces now, gas furnace. Wonderful. Yeah, for every BTU of energy you pay for, you get 96% of those back. But when you go to a heat pump, rather than burning a blue flame to generate heat, you're simply moving heat from indoors to outdoors. A heat pump is 300 to 400% efficient. And yes, it's using a fuel known as electricity, but we're not as worried about that because we know our electricity is pretty green in Ontario. It's greener than natural gas. And we know that we can generate ourselves if we do it right. You don't really worry about the cost of electricity if you know that sometime in the near future or today, you could simply say, I'm making my own. My brothers say to me all the time, isn't the heat pump, isn't electricity expensive? I make my own, it's free, come plug in your car, it's free. I make my own. So it's a really nice match to that solar, if you will. And it's really three to four times more efficient than, say, a gas furnace. I don't need you to look at the technical side. All I want to get at is even when it's cold outside, like minus 10 Celsius, even if it's minus 10 Celsius, that's warmer than minus 20 Celsius. Okay with that? So what a heat pump does is it takes minus 10 degrees Celsius air, passes it through the compressor, takes 10 degrees Celsius worth of heat out of it, makes Westport colder, but makes your house warmer. Everybody okay with that? And that takes 1/3 the amount of energy to transfer that heat than it does to generate new heat with a blue flame. And the knock on it has been, well, it wasn't really set for Canadian climate. That's been fixed. It used an expensive fuel. That's been fixed because we need less of it and we have the ability to generate our own. So heat pumps, and we all know this. Canada's saying to us, we need to get everybody 15 million houses to heat pumps. The problem is you can't do it in an existing house because the heating loads are way too big. The largest practical heat pump that you can buy in a residence is about 60,000 BTUs of heat. The smallest furnace you can buy is about 60,000 BTUs. In other words, old houses have heat losses of 70, 80, 100,000 BTUs. I can't buy a heat pump big enough. You can only really do this in really well renovated buildings or in new construction where the heat loss, heat gain are down. So that heat pumps is interesting. I want to highlight one other element. I've got to watch my timing because I said I have time for questions and got to leave a few minutes for that. The challenge is we have this really low load house, but we still have 1,500 square feet of surfaces to distribute air around. So it's actually really hard to distribute these smaller heating loads and still getting ensuring capacity each space to meet the comfort expectations. And it turns out traditional duct systems just aren't precise enough. I don't know if you know this, but sheet metal ducts leak at the rate of 30%. Wow, they just do. It's just the way the fittings are put together, which is way better than the 100% leakage we used to get out of gravity fed. Anybody old enough seen an old house gravity fed that just allowed warm, moist air to leak? They were 100% leaky. We put in ductwork that's only 30% leaky and we go, yes, that wins. But in new houses, that's not nearly precise enough. We got to be more precise about what we're doing. And just to give you an example of that, if we take in a low load house and put air into the room, which we traditionally do at the floor, notice that it creates this pattern and it kind of distributes okay around the room. Not too bad, right? But then what happens that's warm air rising. What happens when we go to air conditioning? Oops, air conditioning, warm air doesn't rise. Oh, sorry, cold air doesn't rise. So we get this really ineffective distribution of air now that we're cooling. And we didn't used to cool, right? We're using the same heating ducts for cooling and it doesn't do a very good job. So we don't get good distribution of air. And there's a new approach that uses smaller diameter ducts, so it gets into wall cavities much easier. It works with conventional air handlers and it supplies air dedicated to each room, a dedicated system. That each room, instead of branches and trunks, and so trunks and branches, we now have what's called a home run system that takes the amount of heat and cool air that you need and puts it directly into your room. And every duct is sealed and every 100% sealed or 99% sealed, and every duct has a damper in it so you can adjust for your house. It's a new technology that was developed at a $600,000 study by the Department of Energy in the United States in Pittsburgh that's now Watercolour, frankly, again, one of the first builders to bring this to Canada. It's being used by all the large production builders in the United States, those guys who are trying to get, because it's more precise. That's really the point. and minimizes noise. So this home run system that you're looking at, and it's all predicated on this idea that I want to distribute the air. I want what's called throw the air across the room to get better air distribution. And give you a little example of that. Rather than putting it at the floor, we put it at the high wall or ceiling, and it distributes the air much better, a little jet of air. It's up out of the occupied zone so you don't feel it. If you put jets of air at the bottom, you'd be standing over top of it. This is up above your occupied zone, unless you're 8 feet tall. You're in really good shape because it's above you. And you're going, well, could I heat from there as well? And the answer is yes, I can still, because of the throw, get good air distribution. And you start to think about, and this is out of the Watercolor's new model home, these ducts at the top, and you think about the advantages of that. I don't have ductwork to worry about, the curtains aren't flapping, and everything's on the inside, so it's a little more cost effective to operate and run. So you just get this clean, accurate, quiet flow of air. And the key word to me is accuracy. The precision of the amount of air that I need in that room is the important part of that. And what I want to highlight as we finish up is to understand, and hopefully I've shown you, I've only shown you 3 out of what, a dozen features that you need to see, so 3 out of a dozen. I get to promise you that each one of those, the same things that make things more energy efficient, also make them more durable, healthier, quieter, controllable, comfortable. And you remember from those green building programs, they all had pedals or bars or tick marks or points assigned to quiet, healthy, comfortable, safe, durable, right? These elements, the same things that make houses more efficient, also provide us with health, safety, durability, and so on. So really important to do that. So as we summarize that optimized design and got ourselves to that net zero ready house, really powerful to understand that we've not compromised health, safety, durability for any of those elements. And then if we just looked at from a operational side, I want to highlight Ontario, and again, you may not be able to see at the back, crane your neck, squint, come after. I'll even make the presentation available if you want. But there's the carbon dioxide equivalents. Remember I said 3.4, 3.8 tons. This is 3,800. Notice that if I go to a net zero gas-driven house, I'd see a really nice job. When I get to net zero all-electric in Ontario, I'm as close to zero as I can get. Zero from a carbon emission standpoint. You've met your goal. I want to be really clear. If you make a decision today to buy a net zero ready all-electric house, you've already met your 2030 goals. Canada's goals of 40% reduction. And for the sake of a few solar panels, either now or in the future, you've met Canada's goals for 2050, which is zero. Everybody okay with that? One decision in a house that's going to last how long? 200 years. That's the way to think about this. What a shame it would be. Hopefully I'm not driving this too hard, but the debate was green. Is this green enough? And the point is, we are at least on that scale, the energy scale, we have the opportunity to be where we need to be. There's never been this opportunity before, quite frankly, to get to zero up until very recently. So a little more of a challenge in Alberta. They have to clean up their grid, or you'd have to put solar panels in the house. Let's be really clear. If they put solar panels on the house, then of course they can be at zero as well. So just a little example of that. And I just want to highlight, because we're thinking about electrification, we're thinking, is this a good thing? We got power grids to work out. I just want to offer this to you. One of the best building scientists in Canada, Robert Bean, likes to talk about a concept called exergy. And he highlights it this way. A blue flame burns at about 2,000 degrees Celsius. To cook a steak really, really nicely, you want about 350 degrees Celsius. To heat hot water, you need about 60 degrees Celsius. To heat a house, you only need 22 degrees Celsius. Why are we using a 2,000 degrees Celsius flame to bring a house to 20 degrees Celsius? Isn't there other things we could do with that, like making steel, other things that we need in industrial processes? It's as he likes to say, the analogy is, you use a chainsaw to cut a pound of butter. Do we really need that amount of power? And so when we talk about getting to electric, take the politics out of it and go right back to my 101-year-old mother who came from the Depression era, who would say, waste not, want not, right? That why are we wasting the capacity of this flame when we in fact could be doing it with, say, a heat pump or other technologies? Let's avoid the use of blue flames. The same is true in vehicles. Obviously, we need to get rid of fossil fuels in vehicles. And imagine if we got rid of the blue flame in houses, got rid of the flames in cars, the combustion process process in cars, imagine what that would do for the outdoor air quality. Remember, it was the outdoor air quality that we were concerned about, and we cleaned that up as much as possible. So that connection, there's still that connection. The sooner we can eliminate blue flames in houses, the cleaner the outdoor air gets. Isn't that kind of cool? And the cleaner the outdoor air gets, the better we can ventilate our houses and feel assurance, these connections that we have, if you will. And so I would say to you, the houses are green by definition, just by the fact that they're healthier, safer, more comfortable, more durable. You noticed all of the programs required that, whether it was a housing program or community program required that. But I also want to remind you of the connection to the outdoors, because we know that after houses, the next biggest one is the cars we drive. And the easiest thing to do is to stop driving cars. You can't do that. Can't stop driving cars, but could I reduce the driving of cars? Instead of having to hop in, power it up, get it warmed up to go down to pick up something at the store, could I? And most communities, unfortunately, the way development goes in most parts of Ontario, you're pretty much doomed to having to use a car. When you think about Westport, the connections to the outdoors. Stephen, you like to say, it's, you know, location, 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 and you're changing that and saying, no, it's about walkable, walkable, walkable. I thought it was pretty interesting. My son, first thing they did when my son and his wife were looking at buying a house, they looked at where they worked. They said no more than 30 minutes combined drive time, big circle, and they had to be within a walk of, and now they're good walkers, with a walk of, what are all the key things in a 40-year-old's life with 2 kids? Schools. Parks, hospitals, and pizza places. Yeah, so as long as they were within 15 minutes. And that's how they chose the builder. Then they looked within that. And guess what? This happened to be in Kitchener. It was one of the few communities where, in fact, there is you're good friends with TerraView, net zero ready builder. So those nice connections to say, it's good to have the house done, but next would be wouldn't it be powerful to have it ready for it? So I'm going to say to you in the debate, are we green enough? Have we done our bit? Understanding that all builders are going to have to do this in 10 years anyway, that we are closing the loop on 40 years of Canadian building science research. Harold Orr would be really proud of what Watercolours is doing. That's really cool. And the connections are indeed walkable. You have this unique opportunity that's really difficult to find elsewhere, because you can get the house done in many places, but it's tough to get the connections that are walkable in other communities. And understanding that, I'm really imploring you, what a shame it would be. And I know budgets notwithstanding and so on, but understanding you buy a house today, or even in your existing house, if I've really got to get to a house that's at zero, otherwise I'm obsolete. And I love that phrase, the future is here, it's just not evenly distributed. Have you heard that phrase before? I can't remember who said that phrase. The future is here, but it's just not evenly distributed. Well, what I need to know is the future is here, and it's in this market. You now have this ability. So on that basis, if I was arguing for the affirmative, is Watercolours the greenest community? And I'm going to say, I think we won. Is that, or let's put it this way, Watercolours won. What do you think? Pretty cool, right? So thank you very much for that. And I would just say we have a few minutes for questions. Any questions? Yes?
That was amazing. Excellent. Thank you very much, Gord. So, I mean, very compelling, makes a lot of common sense. What would you say are the 2 or 3 biggest obstacles to mass adoption of this approach?
Yep. Of course, I've been studying this a long time. When I tell homeowners about it, they're interested. When I show builders, they're interested. There is a little disconnect. And the problem is buying houses is a really, really emotional decision. And as a result of that, we make those decisions really, really quickly, unfortunately. If we did the math and actually sat back and thought about it, of course we would buy this. So it's really the emotional disconnect, and that's what I'm really proud of Stephen and Kevin and others for doing here at Watercolors is investing in their sales staff, real estate agents, and so on, to help them understand that I don't want to take away the emotion of buying a house, big, beautiful kitchen, and so on. And I want to make sure that in behind that is the understanding that there's these wonderful logical reasons to make an emotional decision. So you might say that sounds like an education issue. It is. There is a challenge. In some communities, it's very clearly development challenges. Here in Westport, I got to get the electrical utility on side. I have to get the services people on side. So there are those issues, but fundamentally, homeowners want this, builders want to build it. What's the disconnect? It's houses are sold really, really quickly, and people don't necessarily think about all of the. So I've just asked you in your house buying decision, slow down just a little bit. By about 7 to 11 minutes. Here it took about 50 minutes for you guys to learn it, but that's really one of the biggest hurdles. So call it a communication challenge. There are some logistical things in the background that make it difficult for some builders, mass adoption, but it's coming quicker than you thought. A great mentor of ours, Sam Rashkin, who was the lead at Department of Energy, chief architect, Department of Energy, who designed the Zero Energy Ready program. He was the architect of the Energy Star program. He said, you thought Energy Star went well, 2 million houses in about 15 years. Zero energy is going to go way quicker than that, and it is happening. It is happening way quicker. So that's encouraging. There was a question here, I think, yes.
So, Gord, you've been involved in supplying HRVs or heat recovery ventilators to the industry for a long time. And we've evolved from HRVs to ERVs, and now we've got heat pump ERVs. The problem I deal with all the time with homeowners, it's all about the price. So they start lessening the quality of the moisture removal in the building, or they turn them off. How is the industry going to approach that or address that here we've got a really tight house, and now we have no way of removing the moisture? And we all know that, you and I know HRVs don't do as good a job in the summertime of moving moisture. Where's the industry going in that factor to make sure these ERVs stay on and remove that moisture and give us the fresh air?
Yeah, I'm okay with that question. It'll be maybe too long an answer, but because I've been doing it a long time. First and foremost, our problem is we call them ERVs. And I know the guy who invented that term, Rick Olmsted, heat recovery ventilators, looking for the perfect technical term, heat recovery ventilator. First of all, nobody knows what ventilation is. If they know it at all, they think it's those little muffin vents on the roof for attic ventilation. They think it's fresh air coming in through the copper line set on their air conditioner. They think that's fresh air. No, that's refrigerant. So they don't know what ventilation is. The U.S., immediately when they started doing this, took it to a marketing expert by the name of Suzanne Shelton. I happened to be with her, and that's an area of expertise. So she said to me, what does this device do? So on and so on. And she said, so what you're telling me is it brings in fresh air. I said, yes. And it reminded me of a story. I was at the National Home Show in Toronto years ago, and it was a 10-day show. You may recall, Dave, 10-day show. And on Tuesdays, the only people that are there are the busload of folks from the seniors' homes, right? And this guy comes wheeling down the aisle in his wheelchair, and I got the heat recovery ventilator sign and so on and so on. And I said, he said, so some sort of furnace then, is it, eh? I said, no, a furnace heats the air, recirculates the air, heats the air. This brings in fresh air, takes out stale air. He says, oh, it's like an air conditioner. I said, no, an air conditioner cools the air in your home, just recirculates. This brings it. And he's looking at me, he goes, so it like brings in fresh air? And I said, yeah. He says, so like it's a fresh air machine? And I said, yeah, I guess you could call it that. And he goes, then why don't you, damn it? And he rolls away. And I should have known then. And what Suzanne Shelton said is it's a whole house fresh air system. You guys answered it really quickly. When would you like fresh air in your home? All the time. Now, some days, well, it's a skunk outside. And my wife said the same thing. I said too long an answer. My wife said the same thing. We'd never had one, built a new house, 1992. She said, oh, this would be interesting to see what these things actually do. Didn't really notice much for the first 6 months. Then, of course, I was cleaning filters and so on. I guess I forgot to turn it back on. She came into the house with, what's going on? Stuffy in here. There's something wrong with the air. I said, oh, I guess I had the HRV off cleaning it. She goes, never do that again. And in the next 30 years, she can tell within an hour. So here's the point I would make is this. It's not because you're building a tight house The reason you need HRV is because you stopped opening your, everybody okay with that? If you're not opening your windows, we all know, we used to get fresh air. Ben Franklin, my mother, opened the windows, you know, so on and so on. We need fresh air in our houses. We used to do it with windows. The way I always say to builders, the good news is here at Watercolours, they're giving you not one, but 2 fresh air systems. They're giving you more and bigger windows than ever before, right? New houses have more and bigger windows than ever before. And when you don't feel like opening those for fresh air, then you have this device. And you can operate it or not, it's your home. But whenever you want fresh air in your home, you either open windows or turn this on. But I don't want to run either. I don't want to open my windows, don't want to turn them. Fair enough. Then just live in air that's not as healthy as it could or should be. That's your choice, right? So it's a choice homeowners have to make. I think it comes right back to education, and it comes back to us techie guys calling things heat recovery ventilators and not understanding that they are, what value they bring is whole house, twice filtered, fresh air. So hopefully that helps. Yes?
Yeah, the question that was posed was, this is the greenest community. Is Watercolour the greenest community? Well, Watercolour is nested within Westport. What would it take for Westport, with its existing inventory, existing activities, et cetera, to be the greenest community?
I love that, and thank you. So it's already got the great elements of the walkability, the connections, the local production, so on and so on. No doubt about it. The big challenge in Westport is the existing housing base, right? So I need to think about what can I do? And you think about, remember the choices and alternatives, better insulation, better windows and so on. What can you get done in an existing house? Like, are you gonna tear off the brick of an old house and re-insulate the walls? That's a big job. What can I get done? I can always top up insulation in attics, pretty straightforward. Can I make a house more airtight? Yes, I can make a house more airtight. What's called blower door directed air sealing. Hire Stefan, don't just put caulking and tape on things. Hire Stefan, he'll exaggerate the holes. Now you go and target air tightness. So here's what we've learned. If you can do there's about 4 things you can do. Attic insulation, walls, windows, basements, and air tightness, so 5 things. But you're not doing the walls because they're brick. The basements may be already finished. The challenge is this: do at least 2 of those 5 things, windows, air tightness, walls, basements, and that generally puts you in the range where you can switch to a heat pump. The problem, as I said right now, with old houses is they need too big a heat pump to make it work. But if I can reduce heat loss, heat gains by air tightness, walls, windows, basements, attics. So if I can do 2 or 3 of those 5, now I can go ahead and put in heat pumps in Ontario. That will make those 3 things will make a 60% reduction. So in terms of the carbon element of green, that's where you head. And I'm going to say to the real estate agents, from this day forward, the minute you sell a house, I want you to think about, give people 3 to 4 weeks between closing and move in. In those 3 to 4 weeks, what could I get done? Could I do the windows? Yep. Could I do air tightness? Yep. Could I redo the basement? Yes. Could I put in a heat pump? Done. So it's a perfect time as ownership changes hands when the house is empty to do those 3 or 4 things. And there are some grant monies available, greener grants and so on. So, sorry?
Many of the programs also evaluate things external to the house. For example, the Living Community Challenge talks about things more than just
Absolutely. So I'm going to say, again, my bent, perhaps, my priority tends to be the house itself, got to reduce its emissions, its greenhouse gas emissions. But by all means, then we look at other community elements, waste reduction, trees, natural cooling, natural ventilation, cleanliness of water, all of those things. So those are all more on a community scale. My expertise is more at the housing scale, so that's kind of what I was asking there. Yes? Yep. So as I said to you, we have the National Building Code of Canada, which is going to be adopted in Ontario. Big change coming next year. No longer will there be an Ontario Building Code. Ontario will be adopting the National Building Code, which is 90% the same anyway. So no big deal there. But the National Building Code has laid out steps, or what they call tiers, that will get us to net zero by 2035. So, most builders would say that's too quick. Most of us building science guys say, no, we can do that. So they're all going to have to do this by 2035. What's really important is Watercolor showing, hey, we did it, we're okay. So it helps other builders. Let's be really clear. Other builders every day are coming to Watercolors and TerraView and Doug Terry Homes and Sifton Communities. We guys able to do that, and more importantly, we're able to sell it cost effectively. So they are very important to, and that's why you guys need to help them be successful. You're going to say, in Westport, they need to be successful, yeah, but they need to be successful so the rest of the province can look and go, boy, if they could do that in Westport, then we certainly can do that in London or Cambridge or Kitchener. So there are builders doing it in various pockets. It's the way our industry's always done. A few dedicated people tend to set the bar. It's the way it's always happened. So it is moving quicker than you might think. And Watercolors is an important element of that to show that they're able to be successful at it. So the reason they're not doing quicker is because they're able to sell houses without it. They'll say, if homeowners asked for it, I'd build it. Homeowners would say, I would ask for it if I knew they were building it. Back to that communication challenge. But code is going to get us there by 2035. And builders like Watercolors are going to enable that. Because it's tough to put something in code that nobody's done before. But now that this is being done, code goes, yeah, we can do that. So hopefully that helps. Sorry, question here. Did you have a question, Ross? No, just leaning.
For the home run systems, is there any brands that are like relatively available for Ontario residents?
Yeah, there's a couple of brands, but the most predominant, the one that came out of Pittsburgh is RIA. It's called RIA.
Yeah, we saw that with the ductary
Yeah,
homes.
yeah, and it's a commonly used duct. Really, all they're selling is a duct that was already being sold, but just doing the systems engineering behind it. So any duct can be used. It's just the system and engineering behind it.
Okay.
Yep. Yes.
Gord, what we're really talking about in terms of new housing is changing our cash flow, moving it from where we used to pay utilities,
Attaboy.
energy, moving it more onto the asset acquisition side of it. I own a grocery store here in town since 2007. I've been moving my cash flow away from my P&L over to my balance sheet and then amortizing the asset over time. And it is a really sound way to run your business. And working with a bank in terms of that, when I'm looking at the whole operation, I'm able to explain that and get support for it. The problem really becomes that we're still amortizing houses over 30 years.
Right.
We're talking about a 200-year asset that, you know, we're expecting people to pay for in 30 years. And yet we're building better performance into those, which does also include more costs. So we get to an affordability point of view. The one question I would say, or the one point I would make is if Westport is going to, or Watercolor Westport is really going to be one of the greatest communities, we need people who work in the community, in the service industry especially, be able to afford to live in the community. And the housing, the financing side of things, the way banks turn around and expect people to qualify for mortgages, is somewhat antiquated based on lower housing
Oh, yeah.
costs to build from the past with higher energy costs, and they haven't caught up. Do you think it's time that the government and the bank and the regulators sit down and say, really, what is a house worth? And if we're going to make it a point of saying it's a priority to create higher performance houses that cost more, should we be allowing people to amortize those over longer periods of time? Or should we be taking some of these things and applying the mortgage to the house and not to the owner?
And these are all, you've made really good points. I'll just shorten it by saying this. Really important partnership was just developed between Ellis Dunn, the largest developer of commercial properties in Canada, the Royal Bank, and Mattamy Homes, the largest builder in Canada. And RBC has made a commitment that they are going to try to find financial vehicles that allow energy efficiency to be better amortized. I'll use your words. So this is happening. Or at least at the start of. Don't know what bank you have here in town, but ask your local RBC rep, they might go, what now? They may not have heard of it because it's at the upper levels, but there is a move afoot, has been. In the US, they solved the appraisal problem because the house is less affordable, you can't appraise. Well, Sam Rashkin, our friend at DOE, went to the Appraisal Institute and said, you got to start valuing these houses differently because they're energy efficient. Here in Canada, we still have a problem. All banks assume when they do your principal, interest, taxes, your affordability, they assume your total monthly utility costs are $75 a month. Has anybody paid less than $150, $200 a month in gas, electric, and water? But so we have a problem there. So Royal Bank is trying to address it. You've absolutely indicated another point. What I want to make sure is we don't stop and say, well, we got to wait for that. Don't wait. There are builders who are already doing it. Make those who can make that decision now, because what that does is it makes it more affordable down the road. All the things that cost more right now, the RIA systems and so on, become less expensive and more affordable the more builders are doing it. So those who do have the wherewithal to do this, please do it now. And in the meantime, do know that feds and CMHC and Royal Bank are indeed looking at new vehicles for financing. So hopefully that helps. Yes, we should probably end up, well, I'm happy to stay, but you guys have things to do, but go ahead.
Hi, Gord, you mentioned the U.S. offering money, incentives to builders to improve their efficiencies. I was a builder through the 80s, 90s with the R2000 program. There were grants available then, and I believe that's what pushed the R2000 program into the public accessibility, let's
Yep.
say. It was easy to sell.
Yep.
An R2000 upgrade because there wasn't a lot of cost. Is there any opportunity for incentives to move forward, to speed up this process?
As you know, the incentives are on the existing housing side because there's 16 million of them, so they know they have to spend money there. Codes are all, the feds would say the codes are already going to get us there, so why? That said, utilities and feds have helped builders from the education standpoint. Let's be really clear. The education, the training that I do in Canada is heavily subsidized. The promotional, the technologies, heavily subsidized heat pump technologies. So at the technology end, they are helping builders. Builders don't get a check, but what they get is education, training, support, help, research, and so on. So the feds do help. Province does help a little bit. Utilities help. But I don't see anytime soon an incentive specifically for new houses, other than on the financial end to say, okay, maybe it's a different mortgage vehicle as opposed to an individual incentive. So, I was well versed in that. I will say, Ontario Hydro tried to give out incentives. First they gave it to homeowners, nobody bought them. Then they gave them to builders, nobody bought them. Then they realized they need to give some to the homeowners, some to the builders, so the two will talk together. And all of a sudden the program took off. And then the incentive went away and the program went away. So the problem with incentives is people get loyal to the deal, not to the product. So the problem with incentives, people get loyal to the deal. And we need to be more long-lasting than that. So I do applaud the feds for the development research. Many of the slides I show come out of research that was done by Home Builders Association, Canadian Home Builders, federal government, Natural Resources Canada. So there are dollars being spent on new, just not in the form of individual checks to homeowners. Yes?
To meet the goals that we're talking about here this morning, does Ontario have a grid system to supply all of that power?
Oh, heavens no. Well, yes and no.
Are they willing to jump in and help what we're talking about here?
Yeah, it's, again, really important, and Will Beardmore is going to speak, I think you said in September, and he'll address that, so please come back in September. He's an expert in this. It is very regional as to where you can plug in solar, where you can't. Our grid does have some challenges. Again, I'll say to you, if the grid knew, if the utilities knew that these houses use 1/4, I'll say 1/3 the amount of energy that a standard house would use, they'd get really excited because they'd realize, oh, okay, those 30 houses a year I can now service differently than 30 houses at 3 times the energy. So it allows them to service houses, far greater number of houses with the same service side. So very important to get that done. But so it is very regional at the moment. There is work being done to sort it out. The key from our perspective is to reduce 2 things: reduce overall demand, and most importantly, to reduce the peaks. The problem with electricity is it's not evenly distributed throughout the day. And when you build a zero energy house and you do things like battery storage, you can flatten that peak dramatically. And then utilities go, got it, now I'm good, if they can flatten out those peaks. When you look at the strategy Stephen's employed, like heat pump water heaters and so on, to flatten out electrical water loads, or water heating loads, really powerful for a utility, and they do need to know that. But it's beyond my scope. The good news is Stephen's sponsoring another session here in about a month or month and a half to tackle that question. Well, we probably should say, one, thank you for the question. Let's love that. And I want to thank Stephen and Kevin and their team, and the Cove as well. Always very gracious to do this. What a tremendous opportunity. Imagine how exciting it is for me as I travel North America to see somebody done. right? I see lots of work in progress, and we're trying hard in Atlanta, and Phoenix, and Nashville, but to come here to Westport, Ontario, and from a community standpoint to say, well, we're close to done. We're not done, but we're close to done. All the science is being employed. So thank you very much for your commitment, and thanks everybody on a community level to be interested in this. I really appreciate the opportunity. Thanks very much.